right, question number 8, we're going to be working on limits at infinity. Okay, so in this particular problem, we're looking for the limit as x approaches infinity of x minus 8x to the 15 divided by 2 plus 2 ln x. So we could have used TIEDBO for this particular limit, but we have a scenario. We have something going on here. We have a logarithmic component. Okay, so whenever you are working with infinite limits involving just polynomials, you can use top heavy plus or minus infinity, equal way to divide, bottom heavy 0. But when you have exponential logarithmic functions, they exhibit interesting behavior. So you want to use relative rates for this. Okay. So relative rates as x tends to infinity, we have the following growth rates. The slowest to the fastest, ln x is the slowest, followed by the polynomial function x to the n, and your exponential function is the fastest growing function. Okay, so this is from the slowest to the fastest. All right, so if you have a fast function divided by a slow function, it's going to be top heavy. If you have a slow function divided by a fast function, it's going to be bottom heavy. Okay, all right, so in this limits scenario, like right here, we're going to look at the numerator and the denominator first and ask ourselves, which are the terms that dominate in the numerator and the denominator? Those are the only ones we will consider. Okay, so check this out. This limit becomes limit as negative 8x to the 15. Limit as x approaches infinity of negative 8x to the 15 over 2 ln x. Now, wait a minute. What just happened? Well, what happened is that we took the fastest growing term in the numerator, which is this term right here. How do we know it's the fastest growing one? Well, the power is 15 and this term is 1. Which one do you think will grow faster at infinity? X to the 15 or x to the 1? Of course, it's going to be x to the 15, right? In the denominator, this is a constant, and this is it's a variable function. Although it's slow, it's not a constant. So even slow functions are faster than constants, okay, at infinity. So in the denominator, we took this guy right here, because even though it's slow, compared to 2, it's faster. Okay. All right. So now we have the fastest in the numerator and the fastest in the denominator. Since we have a logarithmic function, let's look here. Look at our growth rates, our relative rates. Polynomial family and logarithmic family. Which one is faster? It's the polynomial, right? So this is a top-heavy scenario. Okay. So in a situation like this, when you have top-heavy, the limit is going to be plus or minus infinity. Okay, so we just have to look at the sign to determine what's the accurate sign is. So this is, let's put a note right here. This is top heavy. And then when it's top heavy, it's plus or minus infinity, right? Okay, but we have a minus here that automatically tells us that we're going to have negative infinity as the answer to question number 8. All right, so our answer is, what is our answer? Option C. So just think about, I want to talk about growth rates. In this particular scenario, the reason why we said it's top heavy is just because we have a negative fast function over a slow function. And towards infinity, the fast function could look like, it keeps going as a fast function, and the bottom basically becomes like a constant. It's like it's not really moving, and the top keeps growing. So in a situation like this, you have negative infinity. That is why our answer is negative infinity. Channel, do give us a thumbs up or a like. Your positive feedback is very valuable to us. Do not forget to subscribe to our channel if you haven't already done so. If you have any questions or comments as indicated earlier, just put it in the comment section below and we'll be more than glad to support you. Tons of support resources can be found at mathgotserved.com, all free. or just take a look on the link in the description below. Thanks again for watching and have a wonderful day. Goodbye.